Hello, everyone. My name is Vikas Kumar, working as an assistant professor in IIMT college. Okay, let's today we will discuss about the topic of operating system, that is process state cycle. First of all, we need to know that what is process. Okay, process is in we consider that is in passive. Process we consider that is in passive. State, and whenever we run the process, that's like in we are writing a program and we creating a word file or PDF file, and or we can say uh, is a task in a computer system, or sometimes we call it is a job in computer system that we are going to perform, we are going to execute in the computer system in our machine. So it is called an process. Process in active state and program is in passive state. Passive program is in passive means we are only creating that program. We are not going to executing this program. Whenever executing this program, then say it is executed by the CPU. It is executed by the processor. Okay. Okay. So, as you know, that there is a program where we are going to execute this program is executed by the CPU. So, what are the states? What are the states? Many states that process is going from the one state to another state, second state to third state, and more. Okay. So, let's we will discuss. Let's see what is in these lectures we will discuss. And yeah, what is in this lecture that we will discuss about that process. What is process and basic operation on process. That's like the creation, create the process, scheduling, schedule the process. Whenever process will go to the CPU systems, we will go for the executions, and the executions how it will be executed by the CPU, and deletion and killing. After completion of that process, what process will be done? Deletion of the process, or otherwise we can say sometimes killing that process. That's key. We can remove the process from our systems. Okay, next is the process state cycle. Two types of cycle, that is 5-state cycle and 7-state cycle. Okay. After that, now scheduler. We will discuss both types of cycles. What is the difference between both being 5 states? What are the 5 state in the 5-state cycle, and what are the 7-state in 7-state cycles? We will discuss both in this lecture. Now, scheduler. As in the scheduling. Scheduling means that we are going to schedule that process from one state to another state. So it can be for like that new state to state, ready to running, running to terminate, or we can go for the waiting and suspended state. Okay. So who will schedule that? Who will schedule that? It is called scheduler. There are three types of scheduler: long-term scheduler, short-term scheduler, mid-term scheduler. All these schedulers have different working principles. Long-term scheduler is using in different states. Short-term scheduler is using in different states, and mid-term scheduler using in different states. Okay. Next process is the we have discussed the process. What is process? Process we consider program is passive state and process is in active state. Okay. Basic operation on that process, as we discussed in the last slide, that we will discuss. That is creation, scheduling, executing, deletion, and killing. That we are writing a program. For example, I am writing a program, and after that, this writing program, that's it. We consider it is in creation of a process. We are create a program. We are suppose I am writing a Word file and I am saving this Word file in my system. That is also in creation of that process. Like that, if you are creating any, that we are going to playing any video. That is also a process for the system. It is that you are creating. And after scheduling. Scheduling means whenever it will be scheduled. Okay, whenever you create a program that you save in your memory, that is in the, we can say it is in the ready state. It is in the ready state. After ready state, we will go to schedule that program, help of the schedulers. We will discuss in the next slides that which scheduler is used in between the ready to running state and new to ready state. So after ready to running state, we will schedule that process. And the scheduling is, there are multiple scheduling algorithms that we will also create. We will also discuss on that topics in another lecture. So scheduling, there are multiple scheduling algorithms in operating system. Using the scheduling algorithms according to the requirements, according to the working of the process of program, we will select which scheduling algorithm should be used, and using the scheduling algorithm, we will schedule that process. Next one is execution. Using the CPU, using the process. processor, we will schedule that execution. Okay, so executions means like we can say that we are using a uniprocessor system. So executions means we are talking about that we are using a uniprocessor system in that topic. We are considering that we are using uniprocessor. Uniprocessor means we have only one processor. Okay, so as you know that the CPU at a time only use can access only one process, not more than one process you cannot run at a time same time. So after scheduling, that you will execute that particular process in the CPU, executed by the CPU, and then we are going to the if process is completed, if process task is completed, and so after that we will go for the termination state. That is, we consider we are removing that process from the CPU, from our system, from CPU. We now freed up the CPU. Okay, next, that is process cycle. There are 5 process state cycle. Process 5, process state cycle. uh, New state, ready state, running state, waiting state, and terminated state. Okay, now we will discuss each and every one states one by one. New state, the process is just being put together. Means like that we can set in these states we are just creating a process. We are just creating multiple processes. There can be n number of processes. There can be n number of processes. We can create n number of processes. That you are creating multiple for the file. You are creating a multiple PDF files. We can say you are creating multiple programs, that like in C program, Python program, Java programs. You can create multiple process. There is no any limitation on that. You can only create only one process, and after that your one process creations, you will go to the ready state, and that it will be run, and after that completion of that all process, you create another process. No, we can create multiple processes at the same time. Okay. After creating process, we will go to the ready state. Ready. New state to now we will go to the ready state. Sorry, here I writing that firstly running and waiting. So I'm telling you in a sequence, in a order. New state to ready state. Ready state means this process has all the needed resources. Now those processes are completely created. Now we will go to the ready state. We will take that process from the new state to, and we will put in the ready state. Means like that we consider new state in the secondary memory storage devices. From secondary we select pool of process is batch of process. We consider the collection of the multiple processes, and we will go to the ready state. Ready state is in the part of main memory. It is executing in the main memory. We will store that process in our main memory. Okay. Uh, so ready state means these processes are ready for the running. They is ready for the CPU. These processes ready for the resources of the systems. They want to resource of our computer system. Their resource can be any resources. That's like the CPU. That can be input output devices. Many. Okay. So so next one is the waiting state. Waiting state means for an event, there can be any event. Event means like that we consider if you giving any commands, that's due to this commands, process need any input output devices, in any hardware devices, or any need interaction with the human beings. So during this process, we will go to the waiting stage. We will go to the waiting stage till this event is not completed. After completion of this event, we will process will go to again the ready state. Okay. Next one is the suspended state. That is called that is the suspended state. Suspended state is that we can say that it is an 7-state cycle part. So we will discuss in the next cycle. So now states now it is terminated. Terminated means the when process is running, completion of the process is completed. Running of the process is completed. We will go to the terminated state. Okay, means there is process task is completed, and now we will go to terminate that process from our systems, and we are freed up the CPU. Okay. Next, like the process state cycle, that 7 states. We are adding 2 more states in that previous 5-state cycle. So in last slides, we discussed new state, ready state, running state, waiting state, and terminate state. These are the 5 states. Basic diagram of our process state cycle is this one. Now we will add 2 more process: suspended ready and suspended wait. Okay, suspended ready means the process in the ready state in main memory, as we know that process in the ready state, okay, is moved to suspended ready state due to the lack of resources. As you know that if there is a limitation of the primary resources, we can say that there is a limited number of that is memory, primary memory, that we can say that we have a limited amount of the main memory in our systems. If we are save the process in main memory that we are using ready, okay. So when ready state means when, let's say example, there is a new process created that is a higher priority process that it needs to run before the old process. So we are going to we are taking that process from new state to, and we are moved to in the ready state, but there is no space in that memory. So how we can free up that space? So what we will do, we will do with some one process that is not having a high priority, we will move to the suspended ready state, from ready state to suspended ready state. This is the secondary storage part of the secondary suspended ready state. So after that, suspending once though from ready to suspended ready, we will, that's high priority task from new to ready state we will take, we will carry, and after that we will run that particular process and termination that process. Okay. So after termination that process, now we will check that there is any free space in the ready state. If there is a free space in the ready state, we will again resume that process from suspended ready state to ready state. Okay, next in the suspended wait state. Suspended wait state, it is working like as in suspended ready state, but it is working on the waiting state. Okay, as you know that there are multiple processes that say they need some input output request, and they some need some hardware devices, and there is a need human interactions. So when our process in the running state and there is some needs in any input output devices, any like we can say any human interaction or required any hardware, then this process go to the waiting state. So there can be many process in waiting state. It is also part of the main memory, ready state, running state, and waiting state. These all are the part of main memory. New state, suspended ready state, suspended waiting state. These are the part of a secondary memory. Okay. So after running states, after process go to waiting state from running states. So let's example someone process that's who need urgently some input output devices, and then we will go to we will take that process to waiting state, but there is no space in the waiting state because process is very filled up. Waiting state process is space is very filled up, so already filled up. So what we will do some process, we will move some process from waiting to waiting suspended, means we will suspend some process for a particular time, and we will move that from process that's who need urgently some input output requires some human interaction or some hardware devices. So that process we will move from running state to waiting state, and then after completion of that process we will take this process to ready state. If someone process go to the suspended waiting state, so if it is for a long time in the suspended waiting state, then we cannot resume. We will not resume that process. If this process is for a similar time of suspended waiting state, then we will again resume and we will go to that process in the waiting state. Okay, but it is for a long time in suspended waiting state. Then what we will do? We will take into suspended ready state, and after that we will go to the ready state. Okay, this is the 7-state cycle of ours. We added 2 more states: suspended ready state and suspended waiting state. So I hope you clearly understand so that's what is the working nature of that process state cycles, what are the 5-state cycles, what is the 7-state cycle. Okay, so in 7-state cycle we added 2 more process states: suspended ready state, suspended waiting state. Now okay, now we will discuss about the scheduler. Okay, in first slides, during that we will discuss about it. We will talk about 3 type of scheduler: long term scheduler, short term scheduler, and then mid term scheduler. Okay, so long term scheduler is also known as job scheduler. Why? Because in long first of all, we need to know that where long term scheduler is working in between states. So long-term scheduler is working in the new state to ready state. As you know that from new states we selected the pool of jobs, collection of jobs, and we will take these jobs into the ready state. So long-term scheduler is the use for selecting the multiple pool of jobs from new state and transfer to the ready state, scheduling to the ready state. Okay, it's the process from the pool. pulls you can say new state from the secondary memory and keeps them in the primary memory, in the queue. In ready states, we are using the queue in that process state cycle. Okay. The purpose of the long-term scheduler is to choose a perfect mix of input-output bound and CPU bound process among the jobs. As you know, there are two terms, that is two words, input-output bound and then CPU bound process. Okay, input-output bound process means again that if that jobs they need only input output processing. Okay, CPU bound process means they need only CPU. They don't require any input output device. They need only the CPU. So there are there can be two types of jobs, that's the input output bound jobs and the CPU bound process. So if the main task of the long-term scheduler is selecting the similar mixture of the input output and CPU bound process. Let's take examples. We are selecting only the input output bound jobs. Means state will go to the new to ready state or ready to directly running to waiting state because because this job only require input output because there is need only input output devices or some mainly hardware devices, so they don't need any running state. Okay, so they don't need a CPU. So during that time, CPU will be idle, and CPU will be idle, so there will throughput be less, and throughput will be less. Then efficiency of the CPU system is less. So here we are using to that. How can we improve the efficiency of our CPU systems? How can we keep busy CPU as more as okay. Next is the CPU bound process. CPU bound process means that this process they need only CPU requirement. They need only running state. Okay, we will take some jobs from new to ready state, and we are selecting one process from new to ready to running state. So as we know that we are using uniprocessor system, we can run only one process at the same time. Okay, we are going to ready to running states. Okay, so if as you know that there is multiple process in ready state, they need only the CPU. They need only the CPU. So there is multi-programming, increasing the degree of multi-programming. So the long-term scheduler, another responsibility of the long-term scheduler is to control the degree of multi-programming. Degree of multi-programming means multiple programs that we are going to running in simultaneously in the running state. So we are going to control the degree of multi-programming. That is the working of the long-term scheduler. It is used in between the new to ready state. Okay, let's now we will discuss about the next term scheduler. That is the short-term scheduler. Short-term scheduler is also known as CPU scheduler. Okay, short-term scheduler is also known as CPU scheduler. It's working between the ready to running state. Okay. What is the working of this one? It select only one process from the ready state according to the scheduling algorithms. What type of scheduling algorithm we are using? If we are using shortest job first scheduling, then we will select that job have shortest burst time. We will select this. If you are using longest job first scheduling, if you are using the first row scheduling, if you are using the multi-failure feedback queue scheduling, if you are using the priority scheduling, so there are multiple types of scheduling algorithms and CPU. In operating systems, according to the using CPU scheduling algorithms, short terms select that particular process and then dispatch or schedule to running state. Okay, this is the working of the short term scheduler. It is working between the ready to running state. Okay, the job of the short term scheduler can be very critical because it seems that if we select a job whose CPU burst time is very high, then all the jobs after that we have to waiting for the long time. So it is a very critical task of the short term scheduler because we can say it is that short term scheduler. It is that scheduler that will take the process who will go for the running in the CPU. Okay, so there is a critical task of this one, and then okay, so or somewhere that's key. It is a problem called starvation. Starvation means let's take example, we are scheduling a process that's a long process time, long execution times, long burst time, and we will schedule that process from ready to running state. And after that, we take example, there are many processes that's our lowest burst time, or we can say the shortest burst time, then that particular process. And they all shortest process need to wait for a long time. That's how can they go to the running state and when they go to the running state. So due to that reasons, sometimes there can be long burst process can be in our systems, and due to that smaller shortest times process, they need to waiting for the more time. So this is problem is called the starvation. Okay. Now next we will discuss about the medium term scheduler. Medium term scheduler is working between the running to waiting state, waiting to suspended waiting state, and ready to suspended waiting state. Means we can say that it is working between the main memory to the that's we can say that in the secondary memory because running to waiting state is also part of main memory. Okay, it is also used where waiting to suspended waiting state, or we can say waiting to blocked suspended state is also using, and the suspended ready to ready state is also using. Okay, medium term scheduling is also known as process swapping scheduling. Why? Because we are going to swap it out or swap in the process, running from running to waiting, waiting to ready. We are going to swap out and swap in that process from waiting to suspended waiting, and again suspended waiting to waiting. It is swap in swap out process. Okay, ready that is swap out the process from ready state, and now we again suspended ready to ready. That we are going to swap in that process in the ready state again. So due to that reason, we are called this process swapping scheduler. Okay. Medium term scheduler takes care of the swapped out process. Okay, the responsibility of the swapping out the process, and we can say the responsibility of the carry the process from running to waiting, waiting to suspended waiting, ready to suspended ready. The task of this scheduling is done by the medium term scheduler. Okay. If the running state process needs some input output time for the completion, there is a need to change its state from running to waiting. As you know that if there is any process that needs any some input output request, you need any hardware request or need any human interaction, then we are going to schedule that process from running to waiting state. Okay. Such processes are the swapped out process, and this process is called the swapping. Okay. Medium term scheduler is responsible for the suspending and resuming the process. Okay. It reduces the degree of multi-programming. Okay. The shortest of there is a long-term process. Long-term scheduler. It is the responsibility of the control the degree of multi-programming. For example, if you are not controlling the degree of multi-programming, then who will reduce the degree of multi-programming? It is reduced by the middle term scheduler. Medium term schedulers, mid-term schedulers, it control the degree of multi-programming, reduce the degree of multi-programming controlled by the long-term scheduler algorithms. Okay. So these are the 5-state diagram of our that we have 5-state, 7-state diagrams. We discussed the type of scheduler, we discussed in that process state cycle. Okay. So in future lectures we will discuss about the scheduling algorithms, how the scheduling algorithm is used by that scheduler, how they will work, what are the working principle of that all scheduling algorithms. Okay. Okay. Now today we are going to wind up our lectures. Thanks each and everyone.